Hello everyone. So today's discussion will be on charge to mass ratio of electrons and some experiments done by scientists. In the previous video we have discussed about the discovery of electrons. So electron has important properties known as charge and mass. These two are the important properties of electrons. So a scientist called J.J. Thomson was able to give a quantity related to this charge and mass of electrons, known as charge to mass ratio of electrons. Charge to mass ratio of electrons. He was able to give this value. So now we'll see his experiment. The experiment he carried out. He measured the ratio of electrical charge to the mass of the electrons by using a cathode ray tube. He applied electric current and magnetic field perpendicular to the path of the electrons or cathode ray. Now imagine for a few seconds that there is no current or magnetic field. So in absence of this ray travel in a straight line. Remember that one. Now we will discuss this experiment. So at first he only applied electric field. And he observed a deviation towards the point A. So when he applied only electric field, he observed a deviation in the path of the electron or cathode ray towards the point A on the fluorescent screen. Next he only applied the magnetic field and he observed a deviation towards the point C on the fluorescent screen. So by carefully balancing this magnetic and electric field strand, by carefully balancing, he was able to bring the electron to its original path. That means a straight path or a straight line. So this means there is net zero deflection. By net zero deflection means there is equal force between the electric field and magnetic field. As a result of this equal force, there is net zero deflection. So we don't observe deflections. So after his experiment, he was able to draw some conclusions. Deviations of the particles from their path depends on this deviation depends on charge of the electrons or particles, mass of the electrons or particles, strength of the electric field or magnetic fields. So he was able to draw these conclusions based on his experiment. Charge of the electrons. Charge of the electrons. So greater the magnitude on the charge of the electrons or particles, there will be greater interactions between with the electric field and magnetic field. So as a result of these greater interactions, there will be higher deflection. We will observe higher or greater deflection or deviation. So this deviation of particles also depend on the mass of the electrons or particles. Lighter mass will give a low deviation, and higher mass will give a lighter mass will give a higher deviation, and heavier mass will give a low deviation. Strength of the electric or magnetic field. So deviation also depend on the strength on the electric or magnetic field. So on applying higher voltage, the electric field or the strength of the electric field will increase. As a result of this, we will observe a higher deviation. And same as the case of in magnetic field, okay, if the magnetic field strength increases, there will be more deviation. As we have discussed earlier also, he was able to precisely, okay, bring this deviation in a straight line by maintaining the strength, okay, of this electric field and the magnetic field, okay. And through this he was able to calculate by bringing making these two force, okay, electric field and magnetic field equal, okay. So after making this equal, there was no observable deviation, okay, only a straight line. So he was able to calculate the charge to mass ratio of electrons. So from the concept of physics, we can calculate, okay, the charge to mass ratio to the magnetic, okay, and electric field. However, we are not going to discuss how those calculations are done. So he was able to find the value of charge to mass ratio as 1.7558820 into 10 to the power 11 coulomb per kg, where E is magnitude of charge on the electron in coulomb and me mass of the electron in kg. So he was able to give the ratio, okay, of charge to mass of electron. However, the exact value of the charge on the electron, the mass of the electron were not given. So in the next experiment, okay, a scientist called Millikan, he was able to give the charge on the electron through his experiment known as Millikan oil drop method. Millikan's oil drop method. So he was able to give the value of the charge on the electron. So this method or this apparatus is also known as oil drop, because, okay, he used oil to determine the value of charge on the electron. This apparatus consists of chamber, okay, chamber filled with gas. So it consists of atomizer, X-ray, two metal plates, positive and negative, connected to a current source, a telescope, so discuss part by part. Atomizer, okay, atomizer spray, okay, this produce fine particles or minute particles almost the size of an atom, okay. So this atomizer spray will spray the oil droplets into the upper chamber like a perfume. X-ray, okay, from the source. This X-ray, we all know that it is a high energy radiation, okay. So when these high energy radiations, okay, fall on the gases present in the chamber, okay, this high energy radiation, okay, will separate the electron, electron will separate the electron from the gas. And we know that there is a small hole, okay, at the upper plate, okay, where the droplets fall, okay, through this hole due to gravity. So as these droplets fall due to gravity, okay, one more point, this X-ray, okay, when fall on the gas, they will separate the electron from the gas. They will ionize the gas. Okay. So when a droplet fall through this hole, this electron ejected, okay, or separated from the gas, or this ionized gas will give their electron to this droplet, okay, and this droplet will acquire negative charge. So since we all know that two plates are connected to a current source, okay, so what Millikan did was he observed through a telescope and he changed the voltage. We discuss now. We all know that positive and positive repel, negative repel, but positive and negative charge attract. So this plate is positive charge, okay. So two forces are acting on this droplet. One is gravity, pulling the droplet downward, and then this positive charge, okay, pulling the droplet upward. So on adjusting this voltage, okay, the electric field, okay, can be adjusted, and through this electric field, okay, by changing this voltage, okay, the motion of the droplet, okay, the motion of the droplet can be retarded, reduced, or speed up by adjusting the voltage, okay. So he observed through this telescope, and then he adjusted the voltage in such a way that the forces, okay, gravity force and this electric field, okay, he adjusted this voltage in such a way both this field, okay, were equal, gravity and electric field equal, as such that the droplet come to a static position, and he was able to jot down his observation, okay, on every droplets that fall through that hole. So as we have discussed earlier also, there are two forces acting on that droplet, electric field and gravity, okay. He was able to balance this force and then bring that droplet into a static position. As this droplet, okay, gain electron from the ionized gas, they are electronegative, okay, or yeah, their charge is negative, okay. So he was able to calculate the charge on the electron using this experiment, okay, through the concept of physics, okay. We won't go into much detail how he calculated all those data and calculations, okay. We won't go into that. So what he observed through his experiment was every drop is a multiple of particular integer. So every drop is a multiple of particular integer, means charge on each oil drop is n into minus 1.6 into 10 to the power 12 coulomb. He found that the charge on each oil drop is, okay, a multiple of particular integer, this one, okay. So since the droplets comes in different sizes, some big, some small, so the number and value will vary. It will vary as 1, 2, 3. The smallest charge has to be the smallest value. So the smallest value was minus 1.6 n into 10 to the power minus 19 coulomb. So charge on electron is minus 1.6 into 10 to the power 19 coulomb. So through this experiment he was able to find out the charge on the electron. For this he was awarded the Nobel Prize. However, the current accepted value, okay, is minus 1.602176 into 10 to the power 19 coulomb. So since we found the charge on the electron, so through this value we will be able to find out the mass, okay, of the electron. Since in the previous experiment we found already the charge on the charge to mass ratio of the electron. So using this and this, okay, by dividing these two we get the mass of the electron by dividing these two. So we found that charge on the electron is this, and then mass of the electron is this value. Next will be discovery of proton. So since there is negative charge, okay, electrons are negative charge, and scientists believe that there must be positive charge, okay. So Golsin, a scientist, he carried out his experiment on modified cathode ray tube or canal rays, okay. This cathode ray is also known as canal rays. So what modification follows? The modification follows are zinc sulfate is coated behind cathode, but in the discovery of electrons, zinc sulfate is coated behind anode, okay. But here cathode, multiple perforated cathode was used. That means many holes were made, okay, at the cathode electrode. But for discovery of electrons, we have seen that there was one hole at the anode. Gas is filled but at lower pressure, but higher pressure compared to CRT, cathode ray tube, okay. Here low pressure was applied for this experiment, but that pressure is little higher than that of CRT, okay, cathode ray tube. In this experiment, gas is required. Without the presence of gas, this experiment cannot be carried out. However, in cathode ray tube, it can be carried out even in the absence of gas, since the property of the electrons, okay, does not depend on the gas or the electrodes. As you can see, zinc sulfide coating, okay, behind the cathode. There is anode and cathode connected to a current source. So this experiment is taken out at low pressure and high voltage. What he observed was a glow, okay, at the cathode side because of the positive particles, okay, passing through the cathode from anode to cathode. As in the case of discovery of electrons, the rays, okay, the rays or the particles move from cathode to anode. However, in this case it moves from anode to cathode, showing that these are positive charge. And then when we use plates, okay, negative plates and positive plates, This ray get deflected towards the negative plates. This shows that they are positive charge. Now we'll discuss some properties of these positive charge particles. Unlike cathode rays, mass of positive charge particles depends upon the nature of gas. This mass of these particles depend on the nature of gas present in the cathode ray tube. These are simply the positively charged gaseous ions. So these particles are positive charge particles are just gaseous ions. We have discussed earlier. In absence of gas, this cannot be carried on. This means that these particles are produced, from the gas present in the tube. However, in the discovery of electron, we have discussed that the property or the behavior of the electrons are not changed, by presence of gas or electrode, or change of electrode or gas, but in this case they depend, the property will depend on the gas, it will depend. The charge to mass ratio of the particles depend on the gas from which this originates. Mass also depend, on the gas. The charge to mass ratio, we have discussed that on that electron also. We discussed the charge to mass ratio of electron, but for proton the charge to mass ratio will vary for every gas. Hydrogen, take an example of hydrogen. Hydrogen has one electron and one proton. Hydrogen, being the lightest gas, has the highest charge to mass ratio. Has the highest charge to mass ratio value. So heavier elements or gases, they will have lesser charge to mass ratio compared to hydrogen. Some of the positive charge of particles carry a multiple of the fundamental unit of electrical charge. Behavior of these particles in the magnetic or electric field is opposite to that observed for electron or cathode rays. So this behavior is completely different from cathode ray. Their behavior under electric or magnetic field is opposite to cathode ray. As we can see, they deflect toward negative charge, showing that they are positive in nature. As for cathode ray tube or for electrons, since they are negative, they deflect toward positive charge.